I should be live. Yeah. Sweet. Ah. All right. So working on that oscillator again. Not oscillator, I stopped doing I took a break from WAS API and um yeah, I just needed a break from it and I just started wanting to make an oscillator for that synth thing I was making, and I think it's gonna be a pretty big process, but it's called simple synth, but it's definitely not becoming simple. Uh so where's the oscilloscope? Why did I say oscillator? I meant oscilloscope. Yeah, and I started using CMD in Vim. I'm just trying it out. I figured, I don't know. It looks see-through, so it looks nice. Literally, that's the only reason why I changed. Although you can't get icons. Icons don't really show up. But I mean, I don't know, that's not that big of a deal. Syntax highlighting seems to still work and all that. So, I mean, obviously Vim's kind of meant to be in a terminal. So all I did was just kind of like load SDL, and I just randomly drew stuff to the screen. But there's a big problem is that if I try to do run the basic oscillator alongside the oscilloscope, it doesn't seem to work too well. Might be too much going on. Oh, let me change directory to that. What did I call it? Simples. I mean, test os. Yeah, you can hear the oscillator struggling. So honestly, I need to learn more about threads. Um, I really don't know a lot. That'll have to be a different. Um, that'll have to be some other time. But I guess my minimal understanding of threads is that they kind of like alternate. So like you have one thread running, and you have like another thread running, and they kind of like take turns going back and forth. And they're not necessarily I mean, they're not truly independent. They're kind of like, you know, one goes for a little bit, then the next thread goes for a little bit, and they switch back and forth, from what I understand. And you can get race conditions with threads. So if like one thread tries to access a variable before the other one does, it could cause accesses a variable before another one does, it might cause problems. So you could like lock, you could do like mutex locking and things like that. So yeah, um, yeah, that's for the most part all I really know about threads. I mean, I've used them in projects before, but threads I know can get pretty complicated, and I don't know. Everyone seems to say that don't not to use threads unless you need them, and you know it. Eventually, once your program gets so big, you run to that point and you're like, oh shoot. So threads it is. But before I start on the threads thing, I was trying to learn this oscilloscope. I'm in Reactor. Reactor's actually been super helpful. Yeah, it's actually really useful because it has like you can just look at how something was made without, I don't know. It's just super easy to look at how things were made. There's so many tools and synths to look at. But so I was trying to figure out how this oscilloscope worked. And okay. This obviously determines how quick it's picking up the signal. So when I turn this and it shows the frequency or the pitch or the samples, right? Let's go to like samples because this will be easier. When I turn this knob, right? I believe it's going to show this many cycles within the here. Well, I know this. Okay, wait. I know this waveform is 60. The pitch is 60. So I can just go to 60, to view. Let's make it unsynced. So this is now I'm trying to like figure out how to. So, okay, wait, let's explain it one thing at a time. This delay right here, what it does is it continuously records 128 samples over and over and over and over again. And when you put something into this minus or the delay part, how much you want to delay it by, what it does is it takes the index that comes in that keeps reading the sample. So it's reading the samples at a specific index, and then it's going to write that's at that index minus whatever the delay input it is. And with the so it reads and then it puts 128 samples into that buffer, and then it writes 128 samples into that buffer, and it keeps doing that over and over again. And then once it's filled the buffer, it just rewrites the buffer again and again and again. And then it reads the same index. So the same index that's being used to continuously write the buffer is also being used to read it, but you're subtracting it by the delay amount. So the index minus whatever delay amount you have, but if the index minus the delay is less than 0, it wraps back around and it'll do 128 minus the delay amount, so that you're always having a delay, even if the index minus the delay is less than 0. Yeah. Don't know if that made any sense, but that delay is only really useful when you're syncing like to zero cross. See how I'm kind of like delaying the input. And then this just reads up to so RNG is the range. I think that's what that stands for. That's the number of samples there are in one cycle for the specific pitch, samples, whatever unit you're using. So if you're using 60 pitch, the unit of 60 pitch, that sounds weird to say, then this will tell you how many how many samples are in one cycle, because your goal as an oscilloscope is really this. You want to show what one cycle looks like, right? Or maybe like a few cycles. You don't really want to show too much of the waveform because you're trying to look at what the cycles look like, because that's the whole point. So we got the range right here, which is there's apparently 183 cycles with a pitch of 60. I mean, 128 samples in one cycle when the pitch is 60. Yep. So this continues to read. So this has its own, so there's its own buffer right here. This buffer is pretty big. It's, yeah, a large number. But it doesn't, like, it's not going to always write into that big of a buffer. It doesn't always need to. All it needs to write in is the size of the range. So let's say the range is 1. Well, I'll show you what. I'll make the pitch bigger. See, the range gets smaller. As you can tell, like, it can't even show it's, you could tell that there's not even many samples on there. But if I make the pitch, a lot shorter, it's going to be a lot bigger of a number. You see a lot more cycles. So there's a lot more samples for each cycle. There's that many samples for this many cycles, however many cycles that is. Let's change this back to 60. And okay, yeah, you've heard my voice this whole time. Just wanted to make sure. No, whoops. So yeah, then what this does is it keeps, this is a loop, and it will keep as long as the it'll keep counting up, and up based on the input, based on the clock of the input that the input signal we're giving. And every time it gets an input, it'll keep counting up until it reaches, unless it reaches the max size for the buffer. And then it'll stop. And that's the index for the output data. But it'll restart. This counter will restart on different types of conditions. So if I set it back to unsynced, then what's going to happen is it's going to restart whenever this count that's going on here, it's reading it here too. Whenever the count here, that's going to read from 0 to this buffer size, when it reaches the number of samples per cycle, then it's going to restart. And it'll keep doing that. And what the sync thing does, part of the thing that it does, is it restarts it based on different conditions. So for like 0 crossed, once this waveform hits this, it goes past 0, it's going to restart it. Something like that. I don't know if I'm thinking about that, and I think I might be wrong about that one. Somewhere in here. Yeah, the 0 cross. This is just the delayed. So this is one sample. And this is a sample, the previous sample. And if that went from negative to positive, then we're going to send a signal to record that we need to reset. Yeah. Yeah, and you can tell that it like shows the waveform pretty well like that. And then that delay thing from earlier, it seems like the delay also kind of adds more samples into the viewing area. So it looks like by default, this this range, looks like by default that the number of samples in 1 second, that this is probably 183 samples right here that we're viewing because it's 1 cycle. Yeah, so it'd have to be. So by default, it's 183 samples. But then once you turn up the range, you get, I mean, the delay, you also, so you're adding the delay that I was talking about earlier, but you're also adding it to this. So you're adding, this is the time control. Yeah, you're also adding the delay to, yeah, this is all, so this Vx is the number of cycles per second. So you're, this is 183, and then we're adding the delay to it. So now we're adding more cycles for this scope. That's what we're doing here. So we're viewing a few more tiny, like a 1 cycle and like almost a little more than a half a cycle, I guess. So yeah, I was able to understand that much. And then this is like a multiplexed mouse right here, this input. But the thing that was tripping me up about this was the display. Like there's so many multiplex things that I don't know, it's hard to keep track of sometimes. This just looks like it changes the amplitude. Yeah, it just changes. Changes the range, the Y range, I guess. But yeah, the wave display is the thing that's a little tricky. You got more multiplex things. What is this? Oh, an init. Yeah. Yeah, this is definitely just a little bit tricky. Look at how many like multiplexed stuff there is just in general. I'm assuming drawing in Reactor isn't the easiest thing to do because it's not really meant to draw things on. So, but if I knew the reason why, like I get this is RGB value, RGBA values. This is some X value, and Y values for for drawing on here somewhere probably. I don't know, X, I don't know what, some different type of X and Y values, like range maybe, I don't know. But if I knew specifically, like, it's so cryptic, some of the namings, that like, I don't know, it takes a while to try to figure out like, why are you doing this? What is this for? So I'm assuming this is just different color values and X and Y positions for different lines. I didn't even know there was a record line. Yeah, I don't even know. Yeah. But my oscilloscope doesn't do most of that. I just tried to draw the screen for now and then try to do that, you know, just get how many samples from 1 cycle, in the future, which, what is it, like sample rate divided by frequency gives you that. So, yeah. So let's get rid of this oscillator thingy. I just wrote, so So if I'm restoring it back to like how it was, so I have what, 16 bits of data, and then I just write that data from negative 320, negative that number to positive. I don't know. I don't know the specific range for 16 bits. I think it's like negative this number to positive this number plus one, something like that. But I just wrote that in the buffer for 16 bits. And then I just gave the scope that data, and it should just like ramp up based on that. Yeah, and that's what it does. But I'm wondering in the future if I'm gonna have to change the way I draw. I'm just using SDL's rendering, so that might have to change. I don't know, but if I press minus, I can, well, yeah, you can slow it down to the point of being at 0, and then it just does that. I can speed it up too, so it takes a little longer. And then you see that the updates kind of like fail at a certain point. Which makes, which is why I have to do that buffer of 128 and yada yada. Not 128, but just a buffer of the number of samples in a cycle. So, yeah, so on to threads now. Oh no, yeah, whatever. My bit rate isn't good, so. Uh, no, I'm just gonna create a whole new project. Yeah, I've been learning a lot of Win32. Yeah, I have like a script to run into to run NeoVim in the terminal because the CL command is really tricky to get to work in specific environments. All right, so threads. What kind of headers do we need? We need this. All right, well, so I need what? Process. threads API. Might have to just include Windows. And then try that. Yeah. There's like a pragma comment, I think. Yeah, there it is. I need kernel, whatever this is. Okay. Boom. Now I can start making threads. Create thread to execute within the virtual address space of the calling process. There is a way to figure out how big your virtual address space is. Like your I don't know. I used to know a little bit more about this. Something about like page sizes and stuff like that. Yeah, there's a lot I need to learn. To create a thread that runs in a virtual address space of another process, use create. Oh. Yeah. Now I'm starting to remember the difference between virtual addresses and another process. Okay, so that's fine. I think everything is pretty much virtual addresses anyways. Like the memory in this program isn't like stored in one neat area. It's scattered, like the memory is kind of scattered a bit, if I remember correctly. Parameters, security attributes, security structure that determines whether the structure can handle can be inherited by a child process, cannot be inherited. We don't care about being inherited by child processes. The initial size of the stack in bytes. So the size, how big of a thread you want to make. Nearest page. I don't remember how big a page size is. I think it's like 2048. I don't know. I better set it to 0 because use the default size. That's probably enough because we're not dealing with large amounts of data at once. Pointer to an application defined function to be executed by this thread. All right, so it's a function address. And probably need to follow these rules for the function, whatever you call it. Pointer to a variable to be passed to the thread. So that's just to put user data to the thread. We used that with pthread. I remember doing that. Flags that would control the creation of the thread. Oh, so you can run immediately, wait till resume thread is called. Pointer variable that receives the thread identifier. And I'm pretty sure that wave out open. I'm pretty sure wave out open needs a thread identifier if you use the thread callback. Yeah, thread identifier. Does this return a thread identifier? The create thread? What was the last? Oh, this is just a pointer to the variable that receives a thread identifier. So that's the thread identifier. Okay. Thread handle. Returns a thread handle. Okay. See what happens. Just try running the program. Because I'm in Linux, like, oh, I can't do that, can I? I still got to do this garbage. Oh, I didn't make a makefile. Can I open kernel? Oh, do I need to name it .lib? Up. Yeah, I bet that's the issue here. Duh, not DLL. It does say lib right here. Let's try that again. Yep. And I think I can do like what is the, isn't there like a get ch or something? I don't care if it's deprecated. I'm not getting any data with it. Yeah, there we go. Now I can just, boom. I guess that's not deprecated. Probably is. Okay. Now we have some delay before it closes. All right, let's try this thread stuff. Can I just call it handle? Maybe I can do that. Is there a specific name for like threads? We want to set the security to null. The size, the default. We don't really need to pass any variables because we're just testing it out. Wait, no. This needs to be thread proc or procedure, whatever. So keyword win API. Let's just define it. I just do that. Thread proc. So we got, that's a third. 1, 2, 3, 4. Pointer available past the thread. We're not passing anything. Also put null. And we want to run immediately. Wow, there's a lot of null and zeros. And then a pointer to the thread identifier. Yeah. Let's try it. Oh, it ran it. Let's try another thread. Copy this. Let's try that. Oh, new line. Let's try a loop here. And let's try passing a variable. What type is this? LP void? Now this is where the race can, well, I guess it doesn't really need, it's not race condition. Yeah, all right. And real quick, I'm gonna look at something. Oh, whoops. I only see the main thread. You know, this could be the reason. Huh. Huh. Maybe oh, I bet this is the reason why they're not running. Yeah. I'm only seeing thread 1. Oh, duh, because I only made thread 1. Oh, I think I understand now. Thread 1, thread 2, thread 1, thread 2. Main thread, hello, I'm thread 1, I'm thread 2, thread 1, thread 2. Stop seeing the main thread though. Oh yeah, I do. I just not as frequent, I guess. Oh, all right. So we made a thread. Oh, no. Let's see if I can figure out how to do like mutex. Huh. Wait for multiple objects. Hmm. So this is how you create a mutex. Mutex, release mutex. Wait for single object. Oh, okay. Handle to mutex. No timeout interval. So we're going to wait for the other thread to get done with this. And then we're going to call it. So then when it gets, so when this is equal to this, then we got ownership of the mutex. Get the thread idea. Huh. I didn't realize you could print the thread ID. It specifies a very specific type, and you're not using that type. Well, maybe that works. Long. Oh, there's an error. Oh, because it was running. Duh. All right, we got the thread IDs. Cool. Thread one. Wait, did they? Can I do a try catch in the win32s? Huh. What? Crazy. I wonder if they have Lambda. Nah, doesn't look like this is C++. Uh, so we're waiting for the mutex. And once we have ownership, we do a thing. And if it's abandoned, we return false. Otherwise, we return true. You know, I've been using std bull, but I wonder if I could just. Oh, all right. Do capital false or lowercase false? It doesn't matter. You can use mutex object to protect a shared resource from simultaneous access by multiple threads or processes. Each thread must wait for ownership of the mutex before it can execute the code that accesses the shared resource. For example, if several threads share access to a database, the thread can use a mutex object to permit only one thread to write to the database. Huh. Create mutex. More reading time. If LP name matches the name of an existing named mutex object, the function requests the mutex all access right. In this case, what is that word? Oh, is it initial? B initial? Yeah, okay. I thought it was like some weird B initial owner. Okay, let's try this. We're gonna create a mutex. Let's not do this main thread thing. Gmutex is another handle. I'll do the wait for multiple objects, why not? Actually, I'm starting to realize something. I think if I just do this. Yeah, huh. Everything that's Windows defined is capital. No, I don't need to include that. Uh, Oh. I don't know which thread's going to cancel first, but one of them will cancel. And when they do, go to the main thread. So these threads will keep going. Once they're done, go to the main thread. Create a mutex. Now, I don't know what this D word thing's all about. So it only tries 20 times before it gives up. Guess that's what it's doing. Yeah, all right. Let's try this. Yep, that makes sense. It's global. La da 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 da. Huh, I didn't know that. Why? If I press GQ, it formats it for me. Use that for other things, but yeah. Let's see if it calls the threads. Thread 1. Does thread 2 ever get called? Oh no. I'm going to count out how many times it does that. Yeah, it only calls thread 1. I wonder if that false and true thing changes it. I don't think so. Oh, then I need to release. Ah, that makes sense. Because I'm hogging it. Thread 1, thread 2. There we go. Thread 1, thread 2. Now they're just going to alternate. And if I remember correctly, there's different ways to alternate between threads. So I was slightly learning this before. Right now, we're just going back and forth between the 1 and the 2. And then once it's done, it should go to the main thread. That might take a while. It shouldn't put as many delays. Yeah, it should. I mean, I would think that it would do this. Thread 2 never. Oh, but quit was true. You know what? If quit's true, then just abandon the thread. Release the mutex. But I don't think. I think I should also return, maybe. Huh. Well, let's see wait for multiple objects does. Yeah. I don't think I understand wait for multiple objects right. Oh, it's open. I think that's what I need. So terminate thread. Uh, wait. Try it now, maybe? Oh, it already executed the main thread. It's weird. Oh yeah, because I set quit the chew. Just do this. It only runs the main thread once? Oh, you shouldn't use this. Alright, well, only in the extreme cases. Oh, maybe it's... Yeah, it's not printing off main thread because I'm not hitting anything. That's what the get ch is. So it's just waiting for me to put an input. Try that. Shouldn't wait for me to get input, I don't think. What about exit thread? Yeah, it's still waiting for me to get input. Whatever. Now it'll go to the main thread. And but so let's look at exit thread. Oh, this function's called explicitly by returning from a thread procedure. Okay. Which means I don't need to do this jazz. I should just be able to do this. If the thread is the last thread in the process when the function is called, the thread's process is also terminated. Terminating a thread does not necessarily remove a thread from the operating system. A thread object is deleted when the handle to the thread is closed. Until the DL installation is done for the process. Oh, they have to wait till DLL initialization is done, and then new threads can be created. Well, until DLL initialization is done for the process, then the thread's created. All right. Let's look up the C runtime library. Oh. A thread is an executable that is linked to the static C runtime library. Well, I think a thread would only be an executable if it was a child, I'm guessing. So that's different. All right, well, I'm gonna take a break. It's been, I feel like a few hours. I'm not sure. Well, got into threads a little bit. Man, eventually I'll continue working on that synth a little bit more and start making that oscillator. I mean, not oscillator, oscilloscope.